Thank you so much. Well, thank you so much. Thank you again for the organizer, and also thank you for inviting me to be here, to be the face to speak on behalf of SEGi. And I believe that by the end of this session, I am able to draw you guys, to join us, to look at engineering in a different perspective. Okay, so well, allow me to introduce myself. Because I am the one who's going to give the talk today. So I am Dr. Freeda. I'm one of the lecturer in the Faculty of Engineering and Built Environment and IT from SEGi University, Malaysia. Okay, so allow me to introduce myself a bit. Okay, if you can see, it's a bit fancy here. Yeah, so again, that's who I am. All right. I am actually from the family of 6 siblings. Okay, if you can see on the picture right, top right, I believe. Okay, so I got 3 big brothers, 1 younger brother, my sister, and myself. Okay, so for basically my father, he is a government officer last time, and then my mom is a full-time housewife. I think being a professional is in the blood. Okay, so if you can see, if you can see that the one that behind me, that's my 3rd brother, and then going from there is my 2nd brother, my eldest brother, my youngest brother, my sister, and myself. So a little bit of background about them. My eldest brother, he is one of the lecturer as well in University Kebangsaan Malaysia. He is more environmentalist kind of person, so he deal with all the mangrove and things like that. And then my 2nd brother, he is an architect. He has his own firm now. And then my 3rd brother, he is a major. He's working with the Royal Air Force in Malaysia. And then my sister, she is a geologist. She's working with a oil and gas company. Last time she works with Shell for about 10 years. And then now, because becoming a mother with the kids, and things like that, so she's a bit settled down into the management side, but still with the oil and gas. And then myself, okay, I still do engineering. Okay, I'll tell you a bit of story of why am I doing engineering later. And then my youngest brother, he is in Singapore currently. He is a hotelier. He is a manager in one of the hotels in Singapore. If you heard about a Kempinski group, so they are kind of another next level kind of hotel, a bit more majestic kind of thing. So yeah, that's a little bit about our my family. All right, so about my education background. Okay, so I graduated, I obtained my first degree in aerospace engineering in USM, University Science Malaysia from Penang. You would probably be thinking that why aerospace engineering, why so rare? Okay, so last time when I was doing my high school, I am a bit like indecisive about what am I going to do. So I'm a bit kiasu, if you heard about this word. So I took all the subject, the accounting, account, I took pure science, biology, physics at max, because I was like thinking, why not? Okay, so, and I'm not too sure which one I am more gravitated to. So I kind of like do all, and then after my high school, I told myself that that's going to be my indicator. So where am I actually leading myself to? And then I realized that the account that I did compared to the science that I did, so I realized that the account is too easy for me. So I would believe that I am a person, I like challenges. See, I got 3 big brothers, so of course I love to challenge, right? So for me, when I was thinking that accounting, finance, business is kind of like easy for me, so I feel like everybody can do that. So alrighty, so I'll go for science. But science, you have so many kind of science. You have biology, you have physics and math and things like that. All right, never mind. But at least I know that I'm going to the area of sciences. So, and then after my pre-U, that is another indicator for me. So which one I am more gravitated to. And then I start to realize that, oh, my biology, not so good for during that time. So I think that maybe I'm not really keen. So again, I tell myself, whatever decision that I make, it's all based on what my performance, because for me, I do everything equally. So how I do things, it's like, that's how I do everything, right? So, and then basically I realized that my physics and maths is always the excellent one. So I told myself, I think, okay, that's it. It's engineering. It is. But again, I was telling I consult my siblings and all, and I'm a girl. Okay. So do you think that it's going to be very challenging, to be in this kind of field, which is there's a lot of competition between all the men and things like that. And I'll look super tiny. But my mom said that who cares about you, a girl, being a tiny or whatnot? They look at your brain. So I was like, okay, alrighty. So it is what it is. So and then again, I chose engineering for that. And then after that, in engineering, as you can see, there are many kind of engineering. Oh my God, it's so difficult being an adult, right? You have to decide so many things. And then after that, I do research on my own. I was looking at, okay, what's the difference between civil, chemical, mechanical, and all those. And then I start to feel like, okay, what is actually I like, okay? But I believe that my mom contribute a lot on my decision making. I believe that even that my mom, she is a full-time housewife, but I believe I can see that she is a walking dictionary. Whatever that you ask her, she will give you an answer and she will have the answer for you. So, but of course, she's not going to tell you that, mechanical engineering, you will learn about CFD, you will learn vibration and things like that. No, she won't say that to you, but at least she will roughly tell you the idea where or how you're going to end up with your career if you took that particular field, right? So and then when I did my research and then I started to realize, oh, civil, I'm not going to stand on the, outside there, very hot, like with the environment, with, the field work and things like that. Maybe not. And then chemical, I feel like, I might end up in a factory. I was like, maybe not. And then I feel like mechanical engineering. Okay, mechanical sounds so fancy, and I know that you can actually go for many other direction, because there are so many things related to mechanical engineering, so you can actually expand a lot. So I end up with the same field and the mechanical, but more niche, okay, so more specific, which is aerospace engineering. So I must say that when I did my degree in aerospace engineering, I must say that it's probably like about 15 years ago. So I kind of like a bit pioneer during that time. So I believe that I was the 4th or the 5th batch. Okay, so but I know that I kind of like be able to project that. Okay, now maybe this thing is not so fancy now, but I know that probably in down the road, so it will be very interesting. All right, and then I went through my first degree, and then after that, I still indecisive whether I should go to the industry or I should further my studies. Okay, so but I feel like, okay, I can join the industry, but voila, I got awarded by a scholarship to proceed my master's and PhD. So I was like, oh, and they will want to sponsor me until my PhD. So for me, I was thinking like, okay, so chill, 7 years down the road, I have nothing to think about, just proceed with my studies. But as far as I can tell, I am enjoying doing mechanical engineering. And also to be specific in the aerospace engineering. If you can see from the pictures that I'm showing you, so I have this study and life balance, okay, and work and life balance, okay. So it's not that you're just doing engineering and you are one of the women doing engineering, you have to compete with the men, and then you don't have the opportunity to live your life. No, look at me, okay, very colorful life, right? So you design your own life. So as long as you know that where you put yourself, you can succeed anywhere, okay? But again, let me tell you, I know that during my study time, in my whole batch, I got 60, my first degree, there are 60 of us. There's only 7 girls in the class. But well, again, like I said, I love the challenge. So for me, it's not a problem, okay? So when there's a will, there's a way. Okay, so come back to our main agenda, which is I would like to talk about our current engineering and the global adaptation, IR 4.0. Okay, so initially that our SEGi group is actually going to that direction. Okay, so if you can see that what is actually this IR 4.0, you were probably thinking that, okay, what is this? So IR 4.0 is actually the industrial revolution, okay, in which that where our engineering is heading to. Okay, if you can see the difference during the IR 1.0, okay, in which that was what, 1984. So during that time, what are the engineering? What are the changes that you can see? Okay, so first thing first, you must remember this IR 4.0 is actually what we can expect is the change. Okay, the change in technology, the change in the engineering, in which that it will change on how we live, we work, and how we communicate, right? So this is what we have to adapt. If you look at your current situation, you've been actually adapting to this revolution, okay? So if you can see that the first IR 1.0 is during that time, you don't have much of technology involved, right? So, and then it's going to another revolution, 2.0, and then you start to have the introduction of the mass production. Okay, so in which that to begin with, people just not really have this kind of mass production, as in like the factory and things like that. So they just produce one thing at a time, and then after that, the revolution keep going. Okay, going to 3.0, in which that we have a lot of digital revolution. Okay, instead of we have a walkie-talkie, we have a handphone, right? And then now IR 4.0 is something that you can see, in which that you heard before about the Internet of Things. So in which that you are at your gym, but then you can turn on your aircon at home. So that kind of revolution that we want. So in which that in our engineering and how we want to adapt, and that is how I adapt myself in this kind of technology as well. So one thing that is very clear in terms of our learning and our education, okay? So in which that last time we have our teacher with the blackboard and the chalk, and then whiteboard and the marker pen, and then now everything is in the screen, right? And still things can be done, right? So that's the interesting about it. So, and then if you can see that what we as an engineer is actually doing, we are pretty much a problem solver, okay? But again, we are also the person who identify the problem, okay? So not to say that we like to find problem, okay? Pretty much sometimes we create the problems ourselves, and then we will want to improve it by designing something which is better for us to replace, and which means that we solve the problem. Otherwise, you won't see this kind of revolution. It looks like engineers cannot sit still, yeah? We always want to improve things. We always want to do things better. We always want to find things to do, find problems to, you know, to solve and things like that. But again, if you can see, we are enjoying the technology. We are enjoying the how do you call this, sustainability of this, right? So, and we are very comfortable now, right? So, but again, if you can see that, you will probably think that, oh, after this, all this evolution and revolution, so you don't need human anymore to do things. Everything is robotic. But wait, you're not going to lose your job, okay? We still need people or men behind it. But before the digital or the robotics thingy actually works perfectly fine, we have like thousands of engineers, thousands of human behind it who design it, okay? So if you can see that sometimes that you see those unmanned vehicles, okay? So sometimes you do not want to put yourself at that kind of risk. If you look at the military side, they have all this unmanned drone, you know, unmanned glider and things like that. So they are doing something that which is risky, but why you want to put the human at stake, right? So that's how the innovation that we try to implement. So again, we are going to this industrial revolution. So we keep having a lot of improvement, all right? So that's part of it. So being an engineer, it looks like you are all rounder pretty much, yeah? So Okay, a little bit about this engineering. Okay, what are the types of engineering that we actually have? Okay, if you look at the mainstream, the mechanical, the chemical, the civil, the EE. Okay, something that you heard before. That's what I know as well. And then, but after that, currently we have the hybrid. Okay, so we have the mechatronics, which is the expansion and the collaboration of mechanical and electrical. And then we have petrochemicals, we have automotive, we have railway, and even you were probably questioning about mine. I did aerospace engineering, right? So which means that it's more niche area. Okay, I'm just focusing more on the aircraft and spacecraft. But pretty much it's still part of the mechanical engineering, right? But again, I chose that mechanical and aerospace is just to have a little bit more bigger option later in my career pathway. So that is one of my, that is how I think last time. But these days, the choice is yours. Okay, if you want to stay focused on that pretty much a hybrid area, the niche area, go for it. Okay, be a pro. Okay, so instead of you are there, you can be there. Even you're a woman, you can be there. Yeah. All right, so a little bit, okay, so now I'm going to dive into the specific engineering that we have, okay? So I'm just going to give you a quick overview what currently that we have in the market. So pretty much that, what is mechanical engineering? So mechanical engineering is an engineering which is involve physics, material science principle, which is you involve design, analysis, the manufacturing, and also the maintenance. Okay, so if you can see that the evolution, okay, the revolution, if you look at the picture on the left side, is on the design, which is the AutoCAD. Let me tell you a bit of my story. 10 years ago when I was doing my engineering, I was a girl, okay, when we want to go for our engineering design, we have to carry that wooden block thing, okay, and then we have to draw on the A3 paper by hand. So that is how challenging it is. But these days, due to this IR4.0, we have all this software. We have AutoCAD for you to do your engineering drawing. You don't have to use all those ancient kind of type. But of course, it's still the same thing that you're going to learn. It's just that the method and the approach is a bit different. Okay, we go by the revolution, right? And then we also have the programming now. Okay, so in which that we just throw everything to the system. Okay, to do the command. Okay, we just call the command out. Okay, so pretty much that is the evolution. And then also the right side, you can see the computational fluid dynamics. Okay, so last time, again, that we as an engineer, before we try to produce things, okay, we would like to see some sort of prediction. Okay, we will want to see that what could be the outcome. Okay, so what we can improve before we do the mass production. Okay, so last time the engineers, our ancient time, they do try and error, okay, and then like a failure here, failure there. So these days we can try to eliminate those processes. Okay, so then there will be cost and time effective, right? So with this kind of a software, you can try, to do the prediction, to test if, let's say, whether the load that being applied, the stress and the strain, and then how effective in terms of the dynamics of the vehicles and whatnot. So you can run the test by just using the software, all right? So that is how the improvement that we can do, and then we can save a lot of time, all right? So that is part of the mechanical engineering. And then in which that those also the area that you would definitely learn, okay, during your study time, okay, that will be the exposure that we would equip you guys before you jump into the industry, right? So this is another few of the breakdown of the types of the mechanical engineer that you can see in the market. Okay, pretty much the top 5, I would say something that you will probably see a lot. Okay, so the production engineer, they are basically mechanical engineer bracket production engineer or process or manufacturing and the fabrication, quality assurance, and R&D. Okay, you probably heard about all these things. So pretty much that their job scope is more in-depth and detailed, okay, instead of just be very general on mechanical engineering. So if the production, you're just going to really take care the production line to improve whatever that you can improve for the production, for the mass production and things like that, and for the process. So pretty much that you are more concerned and take care of your own area. Okay, so that would be better, right? Instead of one man going to do 10 people's job, right? So, and this is another beautiful picture, okay, that you will definitely going to produce, okay, as an engineer, all right? So you would come out with all these fancy things, okay? If you can see that the picture on the left side is it's from the warehouse, okay? You can see the airflow, okay? You just want to see that in terms of probably the ventilation kind of thing, okay? So you want to see if, let's say that in the picture on the right side, if you can see that, is a concentrated area which is more red in color. You can see that that is a shaft, okay, pretty much. So when the color is more intense, that would be the indicator where it could be catastrophic failure if, let's say, too much load being applied, or high stress, or the impact will be critical. So with this kind of tools that you have in the market, you can do a lot of prediction, okay, before you really manufacture or really produce, okay? So all these are the skills that you will be provided, or not to say provided, you will learn, okay? It's a skill set that you can learn these days, and you can bring it to your industrial or your career later on, okay? And then a few about the, again, the mechanical engineering field, okay? If you are not really sure where you can go after this, they are under the automotive, okay? Aeronautical, aerospace, and then robotics, okay? Oil and gas, building and services, biomedical, okay? Biomedical is the combination of biology and then also in mechanical engineering, but the application more on the medical side. And then you have the food and beverage and renewable energy, okay? And don't worry again, okay? So you have a lot of places for you to attach, okay? So if you can see, this is just a few numbers, okay? There are actually tons out there. And also for us in SEGi, we will also provide some internship spots for you, okay? So we have a few opportunity as well for the students who's really like capable, okay? So if you're good at it, okay, so you will probably have some spots. So we also prepared this kind of internship spot for you guys, okay? So don't worry about it, the opportunity is a lot, okay? So this is about chemical engineering. So if you can see that I can talk a lot for mechanical engineering because it's my forte, okay? That's my field. So when we jump into other kind of engineering, so it will be just a bit surface of it, because I feel like, yeah, because I am more interested on mechanical, but roughly I can tell you that, okay, so pretty much this is about the mechanical engineering, okay? You will look at the plant, there's so many plant out there. So remember that I mentioned just now, chemical engineering will probably settle down in a factory. So yeah, this is a pretty much, it's my overview, okay? But yeah, pretty much it's not an easy task as well, being a chemical engineering. So you have to look at the heat. I believe that last time I remember about the heat transfer and things like that. So you won't experience a factory being burned or things like that. So yeah, at this one, if you have a lot of questions about other kind of engineering, okay, we will answer you during the question and answer, okay? But this is the quick overview that about the chemical engineering, some sort of software, okay? So it's not just mechanical engineering that which is a very fancy, okay? So chemical engineering also, you have this kind of software to help you, to assist you to solve problems and things like that, okay? All right, so same goes to electrical engineering. Okay, so electrical engineering is a discipline where you actually have a lot of application on the equipment, okay, devices, okay, system, okay, which is using the electricity. Okay, so you will probably think about what's the difference between electrical and electronic. Okay, so I can roughly generally say that for the electrical, it is more that more concerned about a large scale production, okay, and the distribution of the electrical power. Or and then for me, the difference between the electronics is something which is much smaller or tiny kind of thing. If you heard about the semiconductor, so that I will categorize as electronics. So that's pretty much the difference between electrical and electronics. But to be honest, I am not very fancy about electrical and electronic, because I was thinking last time I wouldn't be able to see the electricity, you know. So I am a bit more experimentalist kind of person. I like to see things. So if let's say I go by electrical, I can't see the you know, the electrics, you know, and then the resistance, you know, kind of thing. I can't really imagine. So that's why I'm not really keen and gravitated to electrical and electronic. But if you like it, the option is yours. Okay. All right. So this is another part where it is contributed by the electrical and electronic engineering. Okay. So if you can see that all the sensor and then all the devices that you've been using now, you know, to make your life a lot easier, it's all coming from the contribution from the electrical and electronic engineers. Okay, so if you can see that all the wavelength, you know, the satellite giving you the GPS and whatnot, they are all the contribution from the electrical engineering. So if you like to see, if you like to do something like this, you like gadget, you know, like to explore all these things, well, electrical engineering will probably suit you. Okay. And then I believe that this is going to be the last one, okay, in which that civil engineering. So civil engineering is basically a discipline where you deal with, again, the design, the construction, okay, the maintenance, and also the physical and natural built environment kind of thing. Okay, so it is also not limited to your roads, okay, the bridge, okay, the canal, the airport, the sewage system, pipeline, okay, and then a lot of a structural thingy. Okay, so but besides that, if you don't have this, because last time I was actually thinking about, oh, if engineering is doing everything, so it's going to be difficult, right? If let's say engineering is not going to be like separate into a few area, so that will be a lot of things for you to learn, right? So okay, so besides that, okay, so being a civil engineering, you are not just limited to just design the construction, just the building and things like that. Okay, so you got to work hand in hand as well with the contractors, okay, with the architects as well, okay, because all these things is a combo, right? So with that, to ease everybody's job, there is another tools, okay, that we have, which is the BIM, Building Information Modeling. Okay, so in which that all the professional can collaborate together to coordinate, okay, things together. All right, because you're not going to just let the engineer just do the construction. I mean, like the contractor going to do the construction, the architect going to just draw, design the building, and then the engineer going to make things happen. So you can't just leave one person to just do one thing. Okay, so you have to collaborate to make more beautiful things. Okay, so this is one of the platform that the professional actually use, in which you can actually reduce the risk, okay, the project risk, and then you can also improve in terms of the time effectiveness and also, of course, cost effectiveness. Okay, and then the outcome will be more fantastic. Okay, so again, we need this kind of platform tools to help us to make things better. So this is where the adaptation of the IR 4.0 is coming. Okay. All right, so quick facilities that we have in SEGi University in Kota Damansara. Yeah, we do have our mechanical and physics lab, okay, for our mechanical engineering, in which in level 1. So we have all the mechanical properties, mechanical testing equipment, you name it. And then we also have all the hydraulic testing as well. We can do, I mean, like, we will equip all the students pretty much as we can to prep you guys to join the before you hit the industry. Okay, so for the workshop and engineering lab, okay, we do have the CNC machine. If you heard about the CNC machine last time, if you heard before the CNC machine, so CNC machine can do a lot of things. Okay, so not just it can simplify a lot of work as well. Last time, imagine this, I did my drilling using the CNC machine, okay? And some of my friend doing some sort of other kind of prototype using CNC machine as well. So pretty much there are many kind of CNC machines. So this is one of the revolution as well, okay? So I don't have to do the hand drilling anymore. I'll just put it in the CNC machine. The CNC machine can do the job for me, okay? That's why women in STEM can also be successful, yeah? All right, so yeah, if you can see that we have the compression test and about the universal testing machine and also the workshop, okay? This is our chemical lab, okay? Not much that I know about chemical lab, okay? But pretty much that we have a well-equipped our chemical lab, at least, I mean, so that we can produce a very good quality chemical engineering, chemical engineer out there. And then besides that, we also have our electrical and electronics lab, okay? It looks so fancy over here, yeah? So not my forte as well, but pretty much that it is well equipped as well. And then a quick information about our accreditation, okay? Accreditation, we SEGi, we receive our accreditation for each of the engineering, okay? So in which that we are always working on getting the accreditation accordingly, okay? We want to make sure that all the engineers that we produce out there, you have the market and then you can go everywhere, okay? So that's the ticket that we want. And then again, our accreditation is from the Washington Accord, okay? So if you can see that there are a few countries that which is under the Washington Accord, so in which that if you go to any of this country, your engineering cert is useful, okay? It's very useful, all right? So you can jump into and the same recognition as well, okay? So in which that you don't have to worry that you just get the engineering cert from Malaysia, you can't work everywhere. No, okay, you can go everywhere, especially under the Washington Accord. I think after your degree, if you don't want to continue your postgraduate, what can you do? This is what you can do, okay? If you are interested to go into the industrial line, this is the ladder that you can climb, okay? So in which that you get your professionalship, okay? So if Malaysia, you have this IR, you probably heard about it, okay? You have to be a member to the IEM and also BEM, right? And then after that, there are a few things that you need to do, in which that if, let's say, you go after you graduated, okay, what you can do is you have to get work experience, okay? Minimum will be 3 years. And then after that, you can sit for your exam, okay? And then after that, you will get recognized, okay? So having a professional engineer, being an IR, you have another you have another ticket, okay? So you've been recognized. And as well, if you want to join the other one that we have, which is the CEng, which is the Commonwealth one, so you can work in all the Commonwealth country other than just the Washington Accord recognition, okay? So there are a few routes in order for you to get the professional engineering, okay? So other than after the graduate, even if you did your postgraduate as well, you still have the way on how to get the professionalship, All right. Okay, I believe that we have come to an end. I've been talking a lot, okay, and I believe that you have a lot of questions as well. So feel free to hit us, okay? Me and Dr. John will be assisting with the question.
Thanks,
I'll
Dr.
pass to John back.
and Dr. John. Yeah, thank you, Dr. Freeda and Dr. John. I think there's a lot of information to unpack. We may need to get you guys back in to zoom in all the different disciplines. All right, students, I think if you have any questions, please put them in the chat box. I have a few questions on my side as well. So I think, Dr. Freeda, just now you mentioned that there is like wide fields of engineering, right? And then there's some hybrid modes, right? How would you advise students to choose whether to go for something wide or something that is more hybrid?
Okay. Yep.
Dr. John?
Yep, Leon, thank you for the very interesting questions. Is how students choose whether is it hybrid or the mainstream. So if let's say you can share the same screen, maybe Dr. Freeda can share the screen for the mainstream and also.
I'm sharing, hang on.
Oh, you are sharing, okay.
Yep. Okay, it was this slide, yep.
Yep, right. So basically the mainstream is for those who are still undecided, because sometimes it's actually, there's nothing 100% right or wrong, okay? It's actually both. You can choose is at what time, what are the information you have, okay? For example, for instance, for a person that's well determined that I already know all the information I wanted to go towards this industry. So therefore, I want to equip myself to a very, very focused information program, which is towards the hybrid. Example, let's say I'm very interested in oil and gas, and therefore I don't want to learn anything related to other than oil and gas. So therefore, I just go towards petrochemical engineering. However, if you are feeling that I'm still 50-50, I think oil and gas is good, but the what we call the economy may be going up and down due to the COVID. So there will be change in terms of economics development. So therefore, the moment when you finish or graduate your program by 4th year, a lot of things have been changed. So therefore, for those who say that, okay, I want to be much more secure, because if let's say for mainstream like chemical engineering, you can join any field. Example, you want to go to the wastewater, you want to relate it to environment, you want to go to oil and gas, you want to go to plastics, you can shift. That's why it's a wider job opportunities, and you have basic, let's say you have all the basic fundamental knowledge to join this industry. Whereas for hybrid, you learn everything are very, very straight, direct, deep into that field. Okay, you'll be very, very professional, very, very pro. It'll be very focused. However, it'll be very, because it's very niche. The moment when this industry topples or collapse due to the economic downturn, they might have difficulty finding jobs. For example, for instance, like before COVID, oil and gas is a very good lucrative industry. But due to the COVID-19, a lot of industry have to be shut down. Okay, so oil and gas prices slump. So a lot of these oil and gas field people, they have to be, let's say, retrenched temporarily because the oil and gas could not support their salary. So therefore, those who are having chemical engineering program degree students, or let's say graduates, they may switch the moment when they graduate. Is the time on COVID-19. They said, oh, all right, so maybe oil and gas is not the right time joining oil and gas, so I can switch to wastewater. And maybe in the next future, we are maybe talking about plastics, because during COVID-19, a lot of people using a lot of this PPE, plastics, plastic containers, because we order a lot of Grab food. So you can estimate, because right now we are focusing on COVID-19, focusing on the what we call the pandemic. But when the countries is solving this pandemic become endemic, more and more problem arise, because remember what is engineer? Engineer is to identify problem, design, and give solutions. So therefore, engineer will comes out, all right, now we have problem with plastics. So how are we going to solve the plastic thing? So these are the opportunity where people can switch from job to another jobs because of a mainstream program. So basically mainstream programs like chemical, mechanical, civil, electrical. So they can go to another company or another backgrounds. Example, let's say mechatronics, they can cross. Sometimes if it's a very simple thing, they can cross. But if let's say chemical, can they work in mechatronic industry? Yes. Chemical can work in mechanical can work in mechatronics industry. So it means that they can switch. So it all backs to what you want. If let's say those, what I'm trying to say is, if you are very firm that I want to become, example, like Dr. Freeda, I want to work in the aeronautical industry. So just go ahead to go to aerospace, okay? But if let's say during the COVID-19, aerospace is not doing well because all the border costs shut down, so you may have to work in, let's say, anything that have related to aerospace, what you learn. So that's why it is something like it's a strategy. There's no right or wrong, because the moment when you graduate, the timing is right, you get the job very easily. So it's all about your mental attitude. So whenever information you're receiving, so you can choose based on whatever information you have at this moment.
Right, thanks, Dr. John. I like that you mentioned problems just now. What would you say is, like right now, what are the problems, the biggest problems that engineers are trying to tackle at the moment and perhaps in the near future? Like what are engineers trying to solve?
All right. So at the moment, let's say we try to focus in Malaysia first. All right. We let's say scale down into Malaysia issue. So first of all, if it's for civil engineering, okay, civil engineering, most likely you will feel the tremor from the earthquake in the last 2 weeks. Then you saw some of the condominium have some cracks over here. Then you heard some of the news. So maybe in civil engineering, you may go towards what kind of materials that is prone to, let's say, that is able to withstand the shake or the earthquake, okay, to make the building earthquake proof, okay, proof. Or let's say for mechanical engineering. So mechanical engineering, they are looking towards 3D, because everything is very easy to print out. Because we want the things is we design things so fast, and then it's easier for you to do it, let's say, in your house. So therefore, mechanical, they always have very good ideas. So the problem that having in mechanical engineering, maybe I'll leave it to Dr. Freeda to tackle, because she's in the mechanical field. So electrical and electronic engineering. So first for electrical, so energy is one of the, let's say, until now, it is an issue from the previous, it is an issue now, and it's also issue in the future, because we need renewable resources, sustainable electrics. So how are we going to tackle the efficiency of electric from the source, sending from the power plant towards your house? There's energy losses. So maybe they will come up with some, let's say, you have to come up with solar panel, higher efficiency solar panel, and then combine with your electric cars. Okay, so then back to the chemical engineering. So chemical engineering is the most problematic is your environmental pollutions, because of the plastics, because of the wastewater. Okay, we cannot run away from the problem that we created in Malaysia. Example, in Selangor itself, let's say, every now and then, once or twice a month, you will have a water shutdown because of the water pollution. So maybe is it because we know there's pollutions, okay? We know there's a pollution. So how are we going to solve that? So chemical engineering comes up with the membrane, the cheaper material, and so on. So how are we going to create to solve the plastics that come from the wastewater in the river? All right. So these are the problems that normally right now we are facing. Okay. So chemical engineering, maybe Dr. Freeda, mechanical engineering, is there any problems that you guys wanted to solve?
I believe that we always have a problem, yeah. But basically these days, during this time, I was that, especially during the pandemic, the most that I think in mechanical, I would say that the automotive part. Okay, so the automotive part, if you realize that we go by this electric car. Okay, so we don't have to go and to the petrol station. We can charge our car and things like that. But again, there is always a drawback. It's like you cannot win everything. Okay, so I believe that there's one of my friend warning me about this EV car, electronic vehicle car. Okay, yeah, you don't to worry about, because oil and gas is not doing much these days, like what Dr. John saying. So, and then we try to reduce the petrol, and then so they invent this electric car. Now I got another friend was telling me, are you looking, let's say I'm going to drive a BMW, right? So for 400 kilometers, you have to charge once, okay? And then let's say they are traveling from JB to Penang, okay? It's 400 km. And then you are going for holiday, you take your car, but how you want to travel around Penang? You need to take a Grab car. So I feel like, oh, okay, that is not convenient as well. So, there's no winning here, but still, we are still improving this kind of technology as well. So especially in the automotive. So yeah, that's what I can comment about here.
Right.
Thanks, doctors. Yeah, so there you go, students. I think there is a lot of big problems that engineers, and the world is trying to solve right now. So take this as, a sign of demand for engineers, because we really need creative engineers, especially those in the younger generation, to come up with more creative ways to solve all these problems. Yeah. There is a student. There is a question by a student. Is robotics engineering the same with mechanical engineering?
Okay, maybe let me answer first. If let's say Dr. Freeda wanted to add on, maybe Dr. Freeda can add on later after my answer. All right. First of all, mechanical, because mechanical is a mainstream. Robotic is a hybrid, so it's very niche. Okay, so if you feel that I want to build a robot, okay, then you go to hybrid robotic engineering. So what you learn is like you learn how to do programming, you learn how to let's say how from coding to action, how the robot works. All right, that is very interesting. Okay, however, what we learn in mechanical, is slightly different with robotic engineering. Robotic is learn how the coding, what we call how the parts interact each other, but mechanical they do learn as how the air move, how the water move, which we call it fluid dynamics, and then we learn the materials, how the what we call when the materials under stress, or when we pull the material, we bend the material, how does it works? Will it let's say, because mechanical, what we learn, we need to provide support to civil engineering, because they build houses, so they need to know what are the material that is available to support the weight, and then will it bend when we put too much weight? So what is the weak point and something like that? What type of material that is useful when we try to turn or bend? Example, let's say the bridge that is always moving up and down. Okay, there are two bridges. Is actually to build bridge. If it's a static bridge, civil engineering to build a bridge. But if you build a bridge that have a gear that opens up to let the ships or the boats pass through, then the parts that pull the bridge up, okay, that parts that able to support the weight of the bridge is the mechanical engineering. Okay, so that's why if let's say we're talking about, okay, if I wanted to get a job in mechanical engineering in Malaysia, okay, M&E example, mechanical example, we want to know, okay, how the water, the piping, you can learn a lot of things in mechanical engineering. So robotic, I can only tell you it's very focused. It's just robots only. Okay. So, but if let's say your dream is to build robots, then go ahead with your robotic engineering. Okay, because of course, the trend of robotic is actually a fantasy that everyone should have. Example, if let's say you watch anime, you have the Gundam, the robots, okay, that helps you. I think in the near future, we do have robots because we already started to have robots in this industry, let's say manufacturing. Okay, example, Industrial Revolution 3 and Industrial Revolution 4. So 3 and 4, we already started to involve these mechanical arms, robotic arms. Okay, this is considered a robot. So robotic engineering is to build the arm. Okay, to build this kind of robots. So Industrial 4.0, they require a lot of mechanical engineering students because they are going not only to build this robotic arm, they're going to build the whole industry, okay, how they work together, because the conveyor belt itself is under mechanical engineering, because anything that's moving, mechanical engineering. So the demand of factories, okay, smart factories or smart automotive, okay, it is a combination of mechanical, electricals, and also IT.
Would it be, in your opinion, would it be possible, in the future whereby engineers can now work from home? With all this IoT and automation going on.
Yep. So in the future, we will definitely possible work from home because of the IR4.0. When we say that we have this what we call 5G. When we talk about 5G, I said, oh, 5G is coming. Oh, I can download things very fast. That 5G is not for you to download. The purpose of 5G, okay, in your handphone, when we say, oh, Smart Maxis 5G, okay, oh, very fast. But actually, the main purpose of 5G is to incorporate, example, when my whole house or my whole factory all equipped with Wi-Fi and sensors. So anything pass through, they can connect, communicate to each other at a very, very high speed that can react. Okay, that's why if there is anything, so the engineers can work from home. But however, to be honest, managers can work from home. Engineers still have to work on site and hands-on because they are the one who troubleshoots. If there are any issues, I want to go on site and see what happened. I want to do tests. So once they solve this problem, they won't go back home. Oh, there's no more problem. I solved this problem already. Engineer, there's one issue. They're always looking for problem. Once they solve problem A, they will find another problem. They will always very enjoying. Just like you open the door, you have squeaking sound. If you can think, oh, why squeaking sound? Can I add oil? So that is your curiosity, and that is your so-called one of your traits that you may be a good engineer because you always ask why. Can I improve? Can I fix that? I don't want this. That is, if you always ask these kind of questions, congratulations. You're an engineer. You're born to be an engineer. You always ask why and how to fix it, and you're going to fix it your own. All right.
Yeah, like you mentioned, engineers is like constantly looking for problems to fix, right?
Yeah.
There's a few more questions in the chat. Someone is asking, is there something called audio engineering? Is that part of engineering discipline?
Oh, audio engineering. Oh, this is very niche. This is more towards like under, I'm not sure, is it under mass communication or under, this is like DJ. Audio engineering is like DJ when you go to let's say entertainment industry. Okay, you wanted to fine-tune your sound, your voice in your recording. So that is audio engineering. And another, sometimes they work in entertainment industry. Sometimes they work in this so-called they wanted to reduce the sound pollution. Okay, so they identify what is the problem. Example, I want to have a very quiet environment. How am I going to absorb all the sound? Okay, so you study. So the audio engineering, they study everything related to the sound wave. How the sound wave react towards different material, how they react, how it can be, let's say, absorbed, and how we alter, we can change the audio. So it is not quite popular among Malaysia. It's not the mainstream. It's not under the mainstream audio, mainstream engineering. but it's actually very interesting. It's very interesting that to learn how the sound wave react. Okay. And what is the difference between I just continue with the question. What is the difference between the bioengineering and biomedical engineering? Okay, for bioengineering, okay, we are looking into okay, let's say biology versus biomedical. Biology engineering is to how are we going to fine-tune, design things. Example, it's very, again, this is not a mainstream. This is a hybrid, which is the focus on in a cell level. Okay, example, biotech. So biotech is actually very near towards bioengineering, whereby you try to change your DNA. Okay, but biomedical engineering. Okay, so first of all, if it's biomedical, okay, related to biomedical is like the medical purposes in cell level, okay, related to human, related to living organisms. That's why we use bio. Medical means that for medical purposes. Engineering is we try to provide, let's say, materials to give them, let's say, some help. Example, robotic arms is under biomedical engineering. Okay, that is a big one. It can be as small as a very tiny, let's say, medical uses material scaffolds go into your vein, okay, to open up to do your so-called operations. So this is all under biomedical engineering because they try to create technologies to solve the medical problems, okay, that using technology, using machines. So that is under biomedical engineering. But bioengineering, that's not related to medical, but related to biology, which is living organisms. So we try to help them. Okay.
Okay. All right. I got two questions here. It's from Lingish. Okay. The first question, she's asking me about the minimum qualification requirement for SPM result to enroll in the field of engineering. I believe that she is addressing SEGi. Or this one, I'm not pretty sure. I believe that she must go through the brochure, I guess, Dr. John?
Yep. For the minimum requirement, okay, for SPM, you cannot go to engineering first. So for SPM, after SPM, you have to go to foundation.
Foundation, the preparation, right?
Yes, foundation in science. 1 year foundation in science, of course.
But they can do diploma after SPM?
Yes, they can do diploma. Okay, diploma SPM. So again, choosing between diploma and foundation is two different things. Okay, it's just like hybrid and mainstream. Okay, because why? If you choosing foundation, you still can choose. I choose foundation science. I can still choose engineering. I can choose medical. I can choose optometry. Means that I still have a lot of wide variety, because right now, maybe I think what I saw right now, the information is too limited for me. I want to go to university first. I want to see what are the programs. Then you go foundation. But if you go for, foundation. But if you go for diploma, the moment that you sign up for diploma in chemical engineering, you are fixed with chemical engineering. So the more after you say that I took chemical engineering, can I switch to mechanical? It's very difficult because the courses that is, let's say, they are not really related too much. So that's why again, it is for those who have very niche approach. Example, I already know what I wanted to do, and therefore, because example, why you know what you wanted to do? Because your parents is a chemical engineer, your mother is a chemical engineer, your brother is a chemical engineer. I want to become chemical engineer. I want to become chemical engineering. Okay, foundation chemical engineering. That's how when people fix their mind is because is family pressure. Your cousin is a chemical engineer. I don't want to think. You decide for me. There are some people like this. Some people have their own thoughts. Is whereby I want to think first. I want to explore, because right now I still undecided, then go for foundation. Then you choose whatever you feel you are interested along the time, because foundation plus engineering is 1 + 4 years, so totally 5 years. So maybe you can take another 1 year to decide before you go for fixed to chemical, let's say foundation.
All right, thank you, Dr. John. And she also got one more last question. This one I can help to address. Is there something that we can do business based on engineering? So I'm not too sure when you say that the business based on engineering, but if you want to say that if there anything that once you do engineering can join together in terms of the business, I must agree it's a yes. Because I have a few experience where I am an engineer, but what the things that I've been working on is as a business strategies. Okay, so in which that I was working with the automotive industry, so in which that how you would want to promote, okay, your products, or how you want to collaborate, okay, with a different industry or with a different company. If that is what you mean by business, yes, of course you can jump into that, because my background as an engineer, but I still can have a position as a business strategist, because they will require somebody with an engineering background. Because if you don't have engineering background, how are you going to, address a lot of things regarding the engineering, about the manufacturing, how you want to promote your operation, about your products and things like that. And then sometimes engineers, they think a bit differently. So we are actually like, in terms of decision making, and then we can do more calculative kind of thing when we do business. Of course, we are not that creative in terms of, create opportunity. So we let the boss to do that. But in terms of the strategies, how you want to project, yeah, you can do that. And if you are going to talk about how your engineering product, and then you want to sell it, you can do that as well. Okay, so that is what is happening in the market as well. So basically you are as an engineer, and then you innovate some of the products and things like that, and then it turns out to be your own, you as a founder, and then you become a businesswoman. You can do that as well. So yeah, if it's just unfortunate that we don't have that kind of I would say, not to say dual degree, because last time in my previous you can take not to say double degree. I can't remember what was the name of the degree, where you can do 4 years of engineering, and then the last 2 years you add a little bit on the business management or the finance, something like that. So pretty much when you go out there into the industry, you are well equipped to work in the company, to to deal with the engineering and also the business development for that company. So you are very well equipped. So yeah, you have that, but unfortunately we don't offer that. But yeah, okay, I hope that I answer your question. Yeah, I think that's about it. I got no more question.
Students, anyone else have any more questions before we conclude today's session? Maybe just want to highlight a message from KK from SEGi. So I think to enter diploma, you need to have 3 credits in SPM, including 1 maths or 1 science. And if you want to go into foundation or degree in SPM, you need to have 5 credits, including physics and chemistry or biology or mathematics. All right.
So I want to add on. Deng Yi Jin, he said, what if I don't have chance to take physics and still want to do engineering? Good. First of all, if you don't take physics, I'm worried that it will be very tough for you. Suddenly you need to study physics. What if, let's say, you thought that you can take physics, then the moment you go to foundation, or let's say you go to, I'm not sure that, because right now, physics is a requirement. Why we say that physics is a requirement for engineering? Because basically most of our syllabus on calculations are all based from the physics. It means that the fundamentals from your physics. So if you don't have a fundamental knowledge in physics, you'll be struggling. So of course you will say that I can learn, okay, but the question is why you're going to take the certificate. The reason why you want to get this certificate is because you want to get a job. But if you got a certificate but you didn't get A, reason your physics is not too good, you may pass your subject, but you didn't get A. So you may lose in terms of your investment, because we invest in your knowledge. You learn something, you want to get a your degree. So of course you want to fight for the best. I want to get A in all my subjects so that I can be employed with a better salary and I can compete with others. So that's why we always prefer you to do something that you are confident, but not taking a chance that I think I can do well in physics. All right. So that's why things that you need to consider, because engineering, I can tell you, if you like physics, it's easy. But if you don't have physics, then you are a 50-50. You may be like physics, but because you have not explored before, so it's a risk for you. All right.
Oh, I think that's a very, very good advice. Really appreciate Dr. John saying that. Yeah. I think we don't have any more questions. So yeah, once again, we want to thank you, Dr. John and Dr. Freeda, for this session. I think it will be great if we can have you guys back for a more detailed session, maybe in the next few rounds. Right. I want to thank SEGi as well